Imagine waking up one morning and gravity feels different. You open your eyes and immediately sense that something is off. The usual weight of your blanket feels almost non-existent, and as you sit up, you notice that even the simple act of moving feels unusually effortless. You hop out of bed a little too high. Instead of the usual thud of your feet hitting the floor, you find yourself almost floating for a brief moment before landing softly. It's as if the air itself is cushioning your every move. You feel strangely light, like a superhero about to take flight. Your hands, which once felt the pull of gravity, now seem to defy it. You stretch out your arms, half expecting to lift off the ground. That's what it might feel like if Earth's gravity were suddenly halved. The force that has always kept us grounded is now only a fraction of what it used to be, altering our perception and interaction with the world around us. Your weight would be half, making you feel buoyant and energetic. Stepping on a scale, you see the needle point to a number that's shockingly low. You jump, and instead of a quick descent, you hang in the air for a moment longer than expected. This lightness would be a novelty at first. The joy of moving with such ease would bring smiles and laughter. Jogging would feel like gliding, and every step would be a reminder of this new, lighter world. You could jump higher, run faster, and lift objects with surprising ease. The physical limitations you once knew would seem to vanish, replaced by a newfound strength and agility. Everyday chores would become a breeze. Vacuuming, dusting, and other household tasks would no longer feel like a burden. Reaching high shelves or moving furniture would be done with minimal effort. Imagine effortlessly lifting grocery bags or leaping over fences. The mundane tasks of daily life would transform into almost playful activities, making you feel like a child discovering the world anew. However, this newfound lightness would come with its own set of challenges. Balancing would be tricky, and the simple act of standing still might require more concentration than before. Our bodies, finely tuned to Earth's gravity, would need time to adjust. Muscles and joints, accustomed to a certain level of resistance, would have to relearn how to function in this altered state. This change wouldn't just be about feeling lighter, it would have profound effects on our very biology. Our cells, organs, and overall physiology would undergo significant changes, adapting to this new gravitational environment. The implications of such a shift would be far-reaching, affecting not just our physical capabilities, but also our health and well-being. Our muscles, accustomed to working against Earth's pull, would start to weaken. Bones would lose density, becoming more fragile. Even our cardiovascular system, used to pumping blood against gravity, would face new challenges. This weakening wouldn't happen overnight. Our bodies are incredibly adaptable. Over time, we would evolve to suit this new, lower gravity environment. But what would this evolution look like? Would we become taller, our limbs longer, our bones thinner? Perhaps we'd resemble those graceful extraterrestrial beings we often see in science fiction movies. Or would our bodies find a different equilibrium, a new balance between strength and lightness? The changes wouldn't be limited to humans. The entire natural world would undergo a profound transformation. Plants and animals would also experience this dramatic shift. The ecosystems we know today would evolve in ways we can barely imagine. Trees, freed from gravity's pull, could grow taller, reaching for the sky with newfound vigor. Imagine forests where the canopy stretches higher than ever before, creating a lush, green world above our heads. Imagine forests of towering redwoods, dwarfing even the tallest buildings. These natural giants would redefine our landscapes, creating a world where nature's architecture overshadows human creations. Animals would also adapt. Birds might develop larger wingspans, soaring effortlessly in the thinner atmosphere. Their flight patterns would change, allowing them to travel greater distances with less effort, painting the skies with their majestic presence. Land animals could evolve to be larger, their bulk supported by the weaker gravitational pull. This would lead to the emergence of new species, each uniquely adapted to this altered world. Imagine elephants the size of houses or giraffes grazing on the topmost leaves of giant trees. These magnificent creatures would roam the earth, embodying the incredible adaptability of life. This transformation of Earth's flora and fauna would create a world both beautiful and bizarre. The diversity of life would expand, filling every niche with vibrant, thriving organisms. It would be a world where the familiar takes on new, awe-inspiring forms, a testament to nature's incredible ability to adapt. The landscapes would be filled with wonders, each more astonishing than the last, reminding us of the boundless creativity of life on Earth. One of the most significant consequences of halved gravity would be its effect on our atmosphere. Earth's gravitational pull is what keeps our atmosphere in place. With weaker gravity, our atmosphere would become less dense, stretching further into space. This thinner air would affect us in several ways. Breathing would become more difficult, especially at higher altitudes. We might need to carry oxygen tanks just to climb a flight of stairs. The changing atmospheric pressure could also impact our weather patterns. Imagine weaker winds, less forceful rain, and fewer dramatic storms. Our planet's climate would undergo a significant shift, with far-reaching consequences for all life on Earth. Section 5. Reaching for the stars, space travel and satellite woes. Now, for the exciting part, space travel. The dream of venturing beyond our planet has always captivated human imagination. From the early days of stargazing to the modern era of space exploration, our desire to explore the cosmos has only grown stronger. With gravity's grip loosened, launching rockets and spacecraft would become significantly easier. The energy required to break free from Earth's gravitational pull would be reduced, making space missions more efficient and cost-effective. Imagine a future where space travel is as commonplace as air travel is today. Commercial spacecraft could ferry passengers to space stations, lunar bases, or even Mars colonies. The possibilities are endless, and the potential for human expansion into the cosmos is immense. We could explore the cosmos with greater ease, pushing the boundaries of human knowledge and ambition. New frontiers in science, technology, and exploration would open up, allowing us to uncover the mysteries of the universe. However, this ease of space travel would come at a cost. The very satellites that we rely on for communication, navigation, and weather forecasting would face unprecedented challenges. Our satellites, held in orbit by Earth's gravity, would face serious problems. With weaker gravity, maintaining their precise orbits would become increasingly difficult, leading to potential disruptions in their functionality. With weaker gravity, maintaining their orbits would be a challenge. Satellites could drift off course, move unpredictably, or even collide with other space debris, creating a hazardous environment in orbit. We could see satellites drifting off into space or, worse, falling back to Earth. Such scenarios would not only pose a threat to the satellites themselves but also to the safety of people and infrastructure on the ground. This disruption to our satellite network would have a massive impact on our communication systems, GPS navigation, and weather forecasting. The reliability of these essential services would be compromised, affecting daily life and global operations. It would be a small price to pay for easier space travel, but a price nonetheless. As we reach for the stars, we must also consider the challenges and responsibilities that come with our advancements in space exploration. Section 6. A day in the life-leaping cars and lukewarm coffee. Imagine a typical day on this light Earth. You wake up feeling lighter than a feather. You effortlessly leap over your car on the way to work, no longer bothered by traffic jams. At work, you find yourself sipping lukewarm coffee, as hot liquids take longer to cool down in a lower gravity environment. You spend your lunch break playing basketball, effortlessly dunking the ball with each jump. As you walk home, you marvel at the towering trees and the birds soaring effortlessly overhead. Life on light Earth would be filled with such curious adjustments, a constant dance between the familiar and the bizarre. Section 7. The challenges of a lighter world. Despite the initial excitement, living on a light Earth wouldn't be all fun and games. The long-term consequences of halved gravity would pose significant challenges to human civilization. Our infrastructure, designed for Earth's current gravity, would need to be re-evaluated. Buildings, bridges, even our vehicles would need to be redesigned to function safely and efficiently in a lower gravity environment. Furthermore, the changes in our atmosphere and climate would have a profound impact on agriculture and food production. We would need to find innovative ways to grow crops and sustain our population in a world with a thinner atmosphere and altered weather patterns. Section 8. Adapting to a new reality. Despite these challenges, humans are an incredibly resilient species. We have a remarkable ability to adapt and innovate in the face of adversity. Living on a light Earth would demand every ounce of our ingenuity and creativity. We would need to develop new technologies, rethink our approach to infrastructure and resource management, and perhaps even explore new ways of living and interacting with our environment. It would be a challenging but ultimately rewarding journey, pushing the boundaries of human potential and leading us to a new understanding of our place in the cosmos. Section 9. Imagine your own light Earth. So, the next time you gaze up at the moon, remember this. Gravity is a fundamental force that shapes our world in countless ways. A simple change in its strength could lead to a cascade of consequences, some subtle, some profound. It's a thought experiment that sparks the imagination and reminds us of the delicate balance that makes life on Earth possible. Now it's your turn. Imagine your own light Earth. What new wonders and challenges await us in a world where gravity's pull is a little less firm?